A few days back, the Solid.js team posted an exciting new announcement titled Solid Start the Shape of Frameworks to Come. So, yes, Solid finally gets its own meta framework, but what you might not realize is that we are entering a new era in web development where things like file system routing, route nesting, server functions, server APIs, and comprehensive rendering strategies are a must in any tech stack. What's interesting though is that despite the apparent variety in the space, when you really think about it, the majority of frameworks offer the same signal-based reactivity paired with a templating solution and powerful server rendering support. Solid Start does a great job in cherry-picking the best ideas the ecosystem has to offer, so let's spend the next couple of minutes reviewing 7 Solid Start concepts while building a demo app. First, let's make sure you are running on an up-to-date Node version and then go through Solid's project setup wizard. With the project in place, we'll work in the following files. app.tsx is the main entry point into our application. We'll store Solid components under this directory, and we'll use the routes folder to define our file system-based router. The router structure is pretty intuitive, with user routes being mapped to the files defined on the disk. Next, let's jump into the app file and write some code. By the way, you are watching The Snippet, the fast-paced no BS series where we are analyzing various code snippets to better understand useful software concepts. The app component is just a wrapper around the Solid router, which traverses the routes directory and makes them accessible using the file routes component. Next, let's jump into the index file, which will be rendered when users access the root path. In Solid, components are plain functions which group together reactive state with JSX templates. To create a to-do app, we'll start by defining a list of tasks and the title field which will be used to add new tasks to the list. Of course, we are using signals here, since this became the status quo for modern reactivity. Then, in the JSX part, we'll iterate over the tasks using Solid's for component, and then render a task line component, which accepts a task entity as a property. Note that Solid removes the overhead of a virtual DOM and performs UI updates directly in the real DOM. However, in order to ensure an optimized behavior, special components like for or show have to be used. Next, in the footer, we'll capture the user input using the onChange listener and listen for button click events to call the save function. Here, we'll define a unique ID for each task entry and then push that entry into the list of tasks. This file contains a task type and the task line component which are yet to be defined, so let's jump into the task component file to continue our implementation. Task is a straightforward type with an ID, a title, some details, and a done status. Since the task line component accepts some properties, we'll enforce type safety here through task line props. The component itself is presentational, and we are simply rendering some information on the screen. There are 2 things worth mentioning here. First, we can link to a task details page, which will then be mapped in the routes folder. Second, whenever a task is completed, we need to notify the parent component, and this component communication is usually done in Solid by passing a handler from the parent to the child. Before moving to the API, let's quickly jump into the task details file to look at the interaction with the server. First, note that the task ID is passed as a path variable, so we can retrieve it via the use parameter. Then, in a real-world scenario, your task will be stored somewhere on the server as well. An advantage of being a full-stack JavaScript framework is that it is easy to write data loading code that can run both on the server and client. So, through useServer, we tell the bundler to create an RPC instance and not include this code in the client bundle. Now that we've seen how data can be retrieved from the server, let's now look at how we can send and store data using REST calls. Under the API folder, let's create a new tasks file which exposes a post function. Here, we'll retrieve the request body, perform validations if necessary, and persist the data. Then, in the index.ts file, we can simply perform a fetch call when the save button is clicked and pass in the task details in the request body. Of course, we discussed just the basics in this video, so please let me know in the comments if you are interested in a deep dive on this topic. If you feel like you learned something, you'll probably find some of these videos interesting as well. Until next time, thank you for watching.